Hello, welcome to Chapter 4, Trigonometry. So I'm going to do a screencast of Section 4-1, Right Triangle Trig. So I'm hoping this is a review for most of you. I don't know if you've ever heard of SOHCAHTOA before, probably, but the way I write it is the way I originally learned it, so I always can remember what goes over what. So for instance, sine is equal to opposite over hypotenuse. And so these mean the same thing. Cosine is the co part of SOHCAHTOA, so adjacent over hypotenuse. And tangent is the TOA, opposite over adjacent. And so what we have to the right side are the reciprocal functions. And so you can say cosecant is equal to hypotenuse over opposite, but there's not really an easy way to remember this, just besides remembering that cosecant is the same thing as saying 1 over sine theta. The way I remember what is the inverse is, of course, tangent is the inverse will be cotangent. But otherwise, I tend to mess up knowing that cosine goes with secant and sine goes with cosecant. So I just remember that the c's can't be together, the s's can't be together. So you have sine with cosecant and then cosine with secant. I don't know, sometimes I remember things really weird. Here we have 1 over... oh my gosh, and of course I screwed up. Alright, 1 over cosine of theta, that is secant. And then of course cotangent is 1 over tangent of theta. Alright, so now that we understand what these mean, so of course all of these angles totally depend on, all the sides totally depend on the angle. So right here, this is the angle we're interested in. And so, of course, the opposite side is literally the side that's facing the angle. The adjacent is the one that's touching it. And hypotenuse is the longest side of the triangle. So this is what I said already. Cosecant is the inverse of sine. Secant's the inverse of cosine. Cotangent's the inverse of tangent. And then another way to say tangent is sine over cosine. So if you want to look at the inverse, you just flip it. So it would be the inverse sine over cosine over sine. So example 1 is we want to know the exact values of the trig function, of all 6 trig functions of this triangle. So I'm going to try to label it with corresponding colors. So this 33 is going to be the opposite side from our angle theta. This 56 is going to be our adjacent side. And then we have the hypotenuse, which is the 65. So remember, sine is opposite over hypotenuse for so you can just find that. So I color code them so you can see the opposite is going to be 33 over the hypotenuse of 65. Cosine is going to be our adjacent, so that is 56 over the hypotenuse of 65. And then tangent is going to be our opposite, so 33 over our adjacent of 56. So we have 3 of the values checked off. And so if I want to write the other ones, I know that cosecant of theta is just going to be 1 over sine theta. So I just take the inverse, so I just flip it, so I'll have 65 over 33. Cosine, so we want secant. Secant of theta is just 1 over cosine theta. So you take the inverse, let's see, purple. So you take 65, and then you divide by the adjacent, because remember, you flip it, so they switch. So we have 65 over 56. And then the last one, cotangent, is just 1 over tangent of theta. So you take the inverse, so it's adjacent over opposite, so you have 56 over opposite of 33. Cool. So using one trig value to find others. So here, the example 2 says if sine theta is equal to 1/3, find the exact values of the remaining 5 trig functions for the acute angle theta. So first, let me write sine theta is equal to 1/3, And remember, SOHCAHTOA, so this means that the 1 is going to be our opposite. Oops, let me change that color. Oh my gosh. Did I use up your opposite? Green. So 1 is our opposite, and then our hypotenuse is going to be 3. So it's useful to write these out so you can use them for the other, so you can find cosine and tangent, and then once you know cosine tangent, you just take the inverse, and then you can figure out secant cotangent. So right away, we know what the value of cosecant is. Cosecant of theta is going to be 1 over sine theta. So you just take 1/3 and you flip it for, let's see, hypotenuse. So you put 3 over 1, and that would be your cosecant. So we know cosecant of theta is equal to 3. Make a box. So I'll list all of the ones over here. Okay, so interesting. We don't know what the adjacent side is going to be equal to. So let me draw a triangle and then label the sides. Alright. So we know the hypotenuse is going to be 3. We know the opposite side of the angle. So here's the angle. We know the opposite side is going to be 1. And then I need to figure out what this adjacent side is going to be equal to. So we know from Pythagorean theorem that a squared plus b squared is going to equal c squared. So here I have the adjacent squared plus this 1 squared, here 1 will be my b, is going to equal 3 squared. So that's going to be the adjacent side will be, let's see, 3 squared is 9, and we have to get the adjacent by itself, so we subtract 1, because 1 times 1 is 1, so we subtract 1. So the adjacent side is going to be equal to the square root of 8. Because remember, this is actually the adjacent squared. Oops, I don't want that last one. Okay, and then if you take the square root on both sides, we have square root of 8. So here, a way to simplify square root of 8. So let's see, 8 is 2, times 2 is 4, times 2 is 8. So you can take out one of these values of 2, so 2 square root 2. So that's just simplifying the radical. Cool. If you don't understand that, here's 5 seconds to explain. So if you take the square root of 2 times square root of 2 times square root of 2, I mean, that's the same thing as saying the square root of 8. Here, square root of 2 times 2, I mean, that will equal 2, and then times square root of 2. Okay, that little aside. So we know the adjacent is going to be 2 square root 2. Awesome, so now we have our numbers. I can just plug in, find cosine and tangent. Let me write my value of sine. So I know sine of theta is equal to 1/3. Cool. So, okay, cosine theta, we have to find that. Tangent theta, we have to find that. The inverse of cosine is secant, secant theta, and then inverse of tangent, cotangent theta. Awesome. So SOHCAHTOA, ka. The cosine deals with our ka. I feel like a weirdo saying that. Here we go, ka. So cosine theta is equal to adjacent over hypotenuse. So the adjacent over hypotenuse. So that's going to be square root of 2 over the hypotenuse of 3. Cool, that's the answer. Awesome. Cosine theta, kind of ugly. 2 square root 2 over 3. Alright. Sorry for the zooming, it's just hard to write. I'm still learning. Alright, so we have cosine. Let's go ahead, hit that inverse. So the inverse of cosine is secant. You just flip the top and the bottom. So you have 3 over square root of 2, square root 2. That's fine. Like, that's actually okay to leave it. I just prefer to not have radicals on the bottom. So the easiest way to get rid of it is just multiply by 1. So this is a clever form of 1. because multiplying by square root over square root of 2 over square root of 2 is the same thing as multiplying by 1. The identity property, if you multiply anything by 1, it's itself. Cool. So really, secretly, secant is equal to 3. Square root 2 over, well, square root 2 times square root 2 is 2, times 2, 4. That's a better way of writing it, because then you don't leave a radical in the denominator. Cool. Alright, let me write this one up here. So secant of theta is going to be equal to 3 square root 2 over 4. Once again, I just don't like leaving the radicals in the bottom. It just is a lot nicer, cleaner this way. Okay. Last one, tangent. So, SOHCAHTOA. Pick another color. So, TOA. Tangent of theta is equal to opposite over adjacent. So here, the opposite over adjacent. The opposite here is going to be 1. The adjacent is 2 square root 2. Cool. Once again, I don't really like leaving the radical in the bottom. So, I wrote a little too big. So it's multiplied by square root 2 over square root 2. Holy cow, that was ugly. Okay. So here, tangent of theta is 1 times square root 2 is just square root 2 over, let's see, 2 times these two together, square root of 2 times the square root of 2 is equal to 2, so 2 times 2 is 4. Square root of 2 over 4. So tangent of theta is equal to square root of 2 over 4. And then cotangent is just the opposite. So you just flip it, so it's going to be 4 over square root of 2. Oh my gosh. Okay, I hate radicals in the bottom. So it's equal to 4 square root of 2 over 2. So this 2 cancels out, this goes to a 2, and then if I would have went to what I originally had written, if I would have went to what I originally had written right here and flip it, I would have had 2 times square root of 2, which is what I actually get here. So I'm left with saying 2 square root of 2 is equal to cotangent. Cotangent theta, 2 square root of 2. Alright, once again, if you're confused on how I did this, just come during bonus, room 127, Monday, Tuesday, Thursdays. Alright. The next part is special angles. So we know there's 2 triangles, hopefully you remember from geometry or algebra 2, that are special. There's the 30, 60, 90 degree triangles, and then there's a 45, 45, 90. So the special thing about 45, 45 is this is an isosceles, which means that these sides, oops, whatever, who cares, you guys know what I said. So this side length is going to equal to this side length. This angle is equal to this angle. So isosceles means you have 2 side lengths that are the same. Awesome. So to prove that the hypotenuse is square root of 2 times x, just remember that Pythagorean theorem says a squared plus b squared is equal to c squared. And here we know that this side length is equal to this side length, so I can simplify and say, okay, a squared plus a squared is equal to c squared. You can combine like terms. This is going to be 2a squared is equal to c squared, and I'm trying to prove that hypotenuse is the square root of 2 times your side length. So I want to solve for hypotenuse, so square root both sides. The square root of 2 times, well, the square root of something squared is going to be itself, so square root of 2 times a is going to equal c. Here our a is going to be my side length, which is x, and here is c is going to be what my hypotenuse equals. Cool. So that was just a little aside. So here's the table of values for special triangles. So if you're taking sine of a 30-degree angle, sine of 30 degrees is going to be 1/2. Tangent of theta of 30 degrees is going to be square root of 3 over 3. Okay, cool. These are very useful. I'm hoping you'll learn them by using them, not necessarily memorization. So the cool thing with the 45-45 triangle is that you notice that sine, oops, that's ugly. Notice that the sine of theta and the cosine theta are actually the exact same thing. So are the secant and cosecant. And then when you take, since it's the same thing, when you take sine over cosine to find tangent's 1, we take the inverse 1. So 45, 45 are pretty easy to solve. Okay, cool. So, solving right triangles. Find the missing side length. Find the missing side length, round to the nearest tenth if necessary. Alright, so we're finding the missing side length here. I'm going to label this as my hypotenuse. Our angle is 35 degrees. And then this length right here that we're trying to find is x, and it's the adjacent side. Oops, let me fix that color. So this x is the adjacent side, and that's what I'm trying to solve for, is the adjacent. So I need a trig value that uses adjacent and hypotenuse. Oh, okay, cool. So I can say cosine of 35 degrees is going to equal adjacent of x over my hypotenuse of 7. So to get x by itself, multiply by 7 on both sides. So we say 7 times cosine 35 degrees is going to equal x. So you plug that into your calculator and we will find the answer. So we plug in 7 times cosine 35 degrees for x, and we find the length is going to be 5.73. We don't know the units, so I can just leave it like that. Cool. Next one says, suppose a competitor in the swimming portion of the race is swimming along the course shown. Find the distance the competitor must swim in order to reach the shore. So let's go ahead, let's label these sides. So we have theta is 48 degrees. We know that the adjacent side right here is going to be 75 feet, and the opposite side, the opposite from our angle, opposite is going to be x. So opposite is x. All right. So do I have a trig function that uses adjacent opposite? Cool. Tangent. So I can say tangent of 48 degrees is going to equal opposite, which is x. Oops. Opposite, which is x, over my adjacent, which is going to be 75. Get x by itself by multiplying by 75 on both sides. So we have 75 times tangent of 48 degrees, and we will find the answer is 83.30 feet. And of course, since we had 0.2959, we had around 83.30. This is a perfect amount of decimals. Cool. So just around decimals, I mean, technically it was like 2 sig figs, so we could put 83.3. That's fine. Alright, so to find the measure of an angle when the trig value is known, the inverse can be used. So inverse sine, the angle is an acute angle and the sine of theta is x. The inverse sine of x is the measure of angle theta. Blah, blah, blah. So let's say we're trying to find the measure of an angle. That's all it's saying. If we know that sine of theta for earlier, it was 1/3, we want to know what theta is equal to. All this whole inverse trigonometric functions, all that means is, hey, how do I get theta by itself? Well, some people would be tempted to say, oh yes, you just have to divide by sine, but that doesn't make sense. Because when you're trying to solve for a number like x here, yeah, dividing by 3 makes sense because you're multiplying by 3, and so you're doing the opposite operation. So here, sine's actually an operation. So to get rid of the opposite operation, you have to do the inverse. So the inverse of multiplication is division. The inverse of sine is literally taking the inverse sine. Take the inverse sine of both sides. And this would give you theta is equal to, literally says like sine to -1, inverse sine, so inverse sine of 1/3. We could find theta is equal to some number. That's all this is saying. You need to solve for the theta. Well, if you do sine, you do the inverse, which is inverse sine. If you want to find the angle and its cosine. You do the inverse cosine. Same thing with inverse tan if you're trying to find the angle of tangent of some angle. Cool. So here, for the example I was kind of talking about earlier, so here's our theta. So the hypotenuse is 15.7. Our opposite side is 12. So which trig function has opposite and hypotenuse? So it's sine. So sine of theta is equal to opposite, which is 12, over hypotenuse. Here it's 15.7. So if we want to find theta by itself, do the inverse on both sides. So inverse of sine, they cancel out, so we get theta by itself. And then we get sine inverse of 12 over 15.7. So if you take sine inverse of 12 divided by 15.7, you'll find that the angle we measure is 49.85 degrees. Cool. So make sure you check your calculator to see that's in degree or radian mode, because of course that will affect how you write your answer. So some applications of trig use an angle of elevation or depression. So if you're in physics, this is literally the second unit, so 2D motion. Don't worry if you haven't gone there yet. So some applications of trig use angle of depression. So of course depression is like when you're feeling down. So of course this is the angle from horizontal and you're going down. And then there's the angle of elevation. So if you elevate something, you're getting higher. So this is the angle that goes up. So it's always from the horizontal. So if you're going down, you'll add depression. If it's going up, it's elevated, it's getting higher. Elevated, oops. I swear I will work on my handwriting. Cool. So here's an example. A chairlift at a ski resort rises an angle of 20.75 degrees while traveling up the side of the mountain and attains a vertical height of 1,200 feet when it reaches the top. How far does the chairlift travel up the side of the mountain? So we are looking for D, this distance. So this is the hypotenuse. We have, let's see, so our angle is 20.75, so it means this side length is the opposite. And tangent is equal to opposite over, oops, that's not the one I want to use. Oh, okay. Hypotenuse and opposite. So sine. Yeah, sine is equal to opposite over hypotenuse. So we take sine of 20.75 degrees. That's going to equal our opposite, 1,200 feet, divided by hypotenuse. Cool. Oh my gosh, so I have to get hypotenuse by itself. So I can just multiply. I can use D instead, but whatever. So I'll multiply by the hypotenuse on both sides. And then I'm just going to divide by sine of 20.75 degrees. So divide by 20.75. Oh my god. Sine of 20.75 degrees. So all I did was I just want to get the hypotenuse by itself. I don't know if your other math teachers use like butterfly method or like switch it out, whatever. All I did was I swapped these two, like multiply by hypotenuse on both sides, and then divide by sine 20.75 degrees on both sides. So you have 1,200 feet divided by sine of 20.75 degrees. We should find the distance that the hypotenuse is, the distance the chairlift travels up the side of the mountain. And so just a reality check before we plug it in, we know that D is the hypotenuse, so it should be longer than 1,200 feet. Alright, so let's plug it into our calculator and let's double check. Okay, so you have to be careful when you plug this in, make sure your calculator is in degree mode. If you had it in radian mode, you would get an answer like 1,268 or something. Here we have 3,387.05 degrees, so as a reality check, this angle's pretty low, so that means that this 1200 degrees is going to be really, really small compared to this length. It's going to be pretty small compared to the hypotenuse. So if you have a low angle, you can see this height is going to be way smaller than the hypotenuse. I don't know if this picture appears to scale, but if you have a really steep angle, right, the steep angle, this height is going to be pretty long and it'll be closer to the hypotenuse versus the one up here, the shallow angle. You have a short opposite side and a long hypotenuse. This is just to help you understand if your solution is close. Just getting a basic understanding of a reality check to make sure that you know you did it right. Because if you would have found an answer of 1,260, well, I mean, that's bigger than 1,200, but yet that still wouldn't be the correct answer because that's the answer in radians. Alright, so solving a triangle. So we want to solve the triangle. Round the side lengths to nearest tenth and the angles to nearest degree. Meaning we have to solve for HF. Well, we know this one's 90. Surprise! 90 degrees. But we need to solve for this angle, F and H. Alright, so let's power through these. So we round the side lengths to the nearest tenth, angles to the nearest degree. Alright, so 28 is going to be our hypotenuse. We have H is going to be the adjacent side. And then lastly, we have F is going to be the opposite side. So let's just set up our three basic trig functions. So sine of theta, let me write this out. SOHCAHTOA. Alright, so sine of theta is going to be opposite over hypotenuse. Cosine theta is going to be equal to adjacent over hypotenuse. So these are two that we need to find because remember we were looking for opposite and adjacent. So that's the way we can solve for it, is the opposite and adjacent up here. Make this a little smaller. Alright, so let's go ahead and plug in for our two numbers. So sine of 41.4 degrees is going to equal our opposite F divided by hypotenuse 28. So if you multiply by 28 on both sides, you get F by itself. So 28 times sine of 41.4 degrees, oh my gosh, okay, is going to be equal to, so plug it into your calculator, once again, make sure you're in degree mode, it's going to equal 18.52. 18.52, so let's go ahead, put it here, 18.52. Ooh, ugly, but whatever. Alright, so cosine is going to equal adjacent, so that's H over hypotenuse, which is 28. Multiply by 28 on both sides. So we have 28 cosine 41.4 degrees is going to equal H. Plug in and you'll get an answer of, plug it in and you will get an answer, gosh, okay, you're going to answer of 21.00. So here, 21.00. So of course it's 21.0031099, whatever, two digits. But oh my gosh, it even lists the directions. We have to get to the nearest tenth. So F 18.5, H 21.0. The last one that we have to find is just this theta up here. So what will this angle be equal to? Well, I now have all three sides figured out, the hypotenuse, the adjacent side, the opposite side. We have this 90-degree angle, we have this 41.4, we just have to solve for this one. So there's multiple ways you can do this. You can do the route where you say, like tangent of your missing angle is going to equal, let's see, opposite over adjacent. So opposite of that side is 21. Divide by the adjacent of this angle, the adjacent of this angle is going to be the 18.52. So look at that, I have my ratio, I can do tan inverse of the whole side, oh my gosh, and then, you know, I can find theta is tan inverse of 21 divided by 18.52. This is looking pretty ugly. That's one option. Or, if you remember from geometry, the angles of a triangle are equal to 180. So we have 90 for this right here is, oh my gosh. So we know that this angle, wow, that's equal to 90. And then we know the angle we worked with the whole time, 41.4 degrees, plus this mysterious angle, so I'll just call it x. So 180 minus 90 is 90. 41.4 degrees plus x. Subtract. So I'm literally just getting x by itself. So this is going to equal 48.6. Yay, so that's the angle. 48.6 solved to the nearest degree. So it actually would be 49 degrees. Rounding up, because nearest degree. Okay. Oops, I cut into that space. Yeah, so what I was talking about is like here we would get the same answer if we did tan inverse as just knowing the basic laws of like angles in a triangle. Alright, so let's work on part B. And look, we're almost done. And then you have the assignment. Alright, let's power through this. So, I'm going to need to solve for A. I'll have to solve for all three angles. Oh my gosh. A, B, C. Well, we already know the angle of capital A is 90 degrees. Boom, one thing done out of 4. Alright, so let's solve for hypotenuse. That will be the easiest thing to do. So, just separating out. So, Pythagorean theorem says a squared plus b squared is equal to c squared. Remember, the c is actually our hypotenuse. Let's go ahead, plug in, try to solve for hypotenuse. So we have 5 squared, because that's one of the sides, plus 9 squared, because that's the other side, is going to equal, well here, stupid Pythagorean theorem, our hypotenuse is actually equal to a. Hopefully this doesn't confuse you. I just put in the values of our 3 sides. So 25 plus 81 is equal to a squared. If you add these together, you'll get 106 is equal to a squared. Square root both sides. Plug that into your calculator. We get 10.3. So technically it's 10.29. Round up to nearest tenth. And we get 10.3 is equal to our hypotenuse, which is a. So 10.3. Cool. Let me write that in. So we have 10.3. Alright, so let's solve for this angle first. Alright, so I know actually all three sides, so that's totally chill. So I'm going to say tangent of my angle theta is going to be SOHCAHTOA, so opposite here is going to be 5 over adjacent, which is 9. So to find the angle, I have to use inverse tangent. So I take inverse tan of tangent theta, it's going to be theta, and then inverse tan of 5/9. So inverse tan of 5/9 is going to be equal to, so it's actually equal to 29.05 degrees. Remember, we just round to the nearest one. So this B angle is 29 degrees. If you got an answer of 0.507, that's in radians. I mean, that's fine. It's just easier to say it in degrees. And then, of course, since I'm lazy, I say the total degrees in a triangle is 180. So it's equal to 90 plus 29 plus the angle C. Get C by itself. Let's see. Let's do one step at a time. Normally I don't do this. 90 degrees equal to 29 point plus C. Subtract 29 on both sides. Our last angle is going to be equal to 61 degrees. Does that make sense? 60, 70, 80, 90. Cool. 61 degrees. Okay, so that is the whole section. If you guys have questions, let me know. If you need more help with this, you always can check out Khan Academy. Once again, feel free to email me. I will try to respond as soon as possible. Have a great day.